Hello and welcome to his Dr. Ross Maths key skill video on using expressions for consecutive integers. Now often when we're trying to prove statements to do with consecutive numbers, like for example, prove that the sum of three consecutive numbers is always a multiple of 3, that kind of thing, we need to generically represent consecutive numbers. So rather than giving specific examples like, I don't know, 4, 5, 6 are consecutive numbers, they're next to each other, we want some algebraic way of representing any possible three consecutive numbers. So let's just say that we represented some integer as n. So some number that someone's thought of, that's a whole number, as n. What would be the kind of consecutive number after that? Well, let's say we had the number 3. What would be the consecutive number after that? It would be 4 and there would be 5. How did we get the 4 and the 5? We just added 1 each time to get the next consecutive number. So if we had n, the next consecutive number would be n plus 1, it's 1 above, and the next one would be n plus 2, we add another 1. What students often incorrectly do is they say that the next number would be 2n, so they have n and then 2n. Well, that's not 1 more, you're actually doubling it rather than adding 1. So you should add 1 each time to get the next consecutive number. And we could go before that. If we wanted the number before n, it would be n minus 1, then n minus 2, etc. So this would represent 5 consecutive numbers in a sort of generic way. It represents any possible 5 consecutive numbers rather than a specific example. So let's read this. A number is given as n plus 5, where n is an integer. Give expressions for the next two consecutive integers. So if we had n plus 5, what would be the next consecutive integer? Well, we add 1 to it, so it'd be n plus 6. And what would be the next one? We add 1 to it, we get n plus 7. And that is the final answer.